Hello, Internet.
I'm never quite sure how many people are here, which I like. It's not good to think about that. It'll slowly
Hello,
become millions.
hello, Gerben. Hello, Shane. Hello, Urban. Hello, Lloyd. And
Whoa!
Stream Elements.
Stream Elements. All right, my favorite. He's shown up every time.
Trusty Stream Elements.
Gerben, Shane, Urban, Lloyd. Gerben, Shane, and Urban Lloyd. Gerben and Urban, your names rhyme.
Oh, I don't know if I can do that one.
Yes. Welcome, Trizak. I'm sorry, but it's
Trizas.
great. And Arj. Yeah, welcome. Let me share something real quick. We're gonna welcome to office hours. We're gonna talk about effect and such, because it's nice, because it's good, and because I want to convince all of the big AI companies to use it, so that the future is a more reliable, resource constrained one, and not leaky and buggy. I don't know if anyone ever has tried. I'm sure everyone has done some OpenAI image generation. But man, that thing is buggy. Once you generate a couple of variants, clearly their streams are dying and not being so something's not being released back to a pool. Something is leaking. Many things are leaking.
So much stuff is leaking.
It's a leaky place. Where do you want to start? Do you want to show off maybe we should talk about the dad thing, I don't know, next week. Whenever you're ready. I'm not sure when you want to go live with dad bot.
Yeah, we can talk a little bit about the dad bot maybe like next week.
Okay.
There's still a few things I'm working out, but it'll be good for like next week, I think.
Okay. Cool. That's why I was generating some images, some claymation. It was very annoying to do. Okay, so I'm going to share a screen.
Hello, all additional folks who have shown up: Alex and Adam.
Hello, everyone. So yeah, we're going to probably take some user questions. If you want to call in, definitely use the Riverside link, which is in the Luma page. So many apps. And then there's some call-in buttons. So if you have any questions that you would like to ask, ideally call in, because that's just fun and a little more interactive, and it works better for the video, and I don't lose track of the questions in the sidebar. But if you don't want to show your face or your voice, you can also always ask in the Discord or in the Riverside chat is where I'm looking. I know it's like being simulcast to 27 different platforms, but I can only have so many different windows. So yeah, Tanner Scadden asked a question on X, which I will open up, which says, and not the screen I'm sharing, I guess, but whatever. It says, could you do an example of reusable effect atoms? Oh my goodness. It's already here. Would be so helpful to know the best practices for that. And I will give some more context with how oh no, did I close Riverside? No, I didn't. Oof, thank God. I've got to be really careful closing windows. Cool. So, and it could be something as simple as a count atom rendered in two different components with their own counts. So yeah, let me just do a little demo that I prepared here just moments ago. So yeah, reusable atoms. So here is a counter component. It goes up, it goes down. Do you hear the audio, by the way, Maxwell?
I do
hear
not.
any? You do not. I'm not sure if it's being shared. So there's just imagine a pleasing synth ding sound.
I can hear it.
You can hear it?
No. You can hear it
in your
mind.
head. Oh, good. You're simulating it correctly. You're doing your audio oral hallucinations successfully. Okay. If everyone, and it truly doesn't matter. I was just curious for the future if I'll get fancy sound effects. So yeah, it goes up and down. It's a counter. Yay. And this is using effect atom with React instead of use state. Now one could simply use state here, but effect atom is better for a variety of reasons. It's really powerful, and we can get to that some other time. But in this example, you create this little piece of reactive state here, a count atom, and then you use that atom, and it gives you the actual value, the current value, which will be updated whenever you call setCount. So this will mirror the underlying value of this piece of reactive state, no matter where you update it from. And then you also get this updater, this setter here that you can use in these callbacks for the different buttons to increment or decrement. And it all clearly works. This is a slightly simplified version of the code. Now, what happens if we render multiple counters on the same page? Well, you'll see that they're all tied together because they're all referencing sort of in the implementation of this counter. It's a single effect atom reference to this piece of state. So they're all going to share and update this mutable state, which in some instances is totally fine. If you have like one piece of state representing, your some keyboard navigation state. So what element on the page is selected, and you want to go up and down with different keyboard commands. You can use this like you would a Zustand store or Redux store, and that could just be sort of your global singleton view state atom. However, you probably want things like this, different counters to each have their own state potentially, or some other kind of widget that you might have multiples of. So how do you do that? Well, you could define an atom inside of a React component, but then you would have to use memo or something, and that's pretty weird. That's not how you're intended to do it with effect atom, which is probably why I'm getting this question. So there is another method called atom.family, which Q atoms family soundtrack now in your oral hallucination memory bank. And so, what is this? Atom family is a method that takes some kind of identifier. This will sort of be used as a lookup key for atoms. So you're basically creating a set of atoms, a family of atoms that are identified by some unique identifier. And then on the inside of this function, you should return an atom. So it's kind of like a map where the keys are whatever you pass in here as the ID, and the values are some atom instance. So here's an atom 0, and it's being told to keep alive. We can talk what that means about what that means in a moment. And then we have another counter component, and this time this takes an ID instead of just not taking anything and referencing a shared global atom. So now we have this counter family, and we have an identifier for this counter. And it looks very similar, except now we call this counter family like it is a function, passing in whatever the type of the ID is. And so we get back that same count and set count methods. And it looks identical, basically. This is almost identical except for the ID parameter and the fact that we have to call our family like a function. And basically, this is a sort of a mutable map type thing behind the scenes. And when you look up into it, it'll get you the atom that has been created. So you can call this multiple times, and the same ID will get you back that same atom. And now we can specify a certain number of counters here. I have 3 counters, and we'll see that they each have their own independent state. Hooray. And even further, I can drop the number of counters down to 0 and bring it back up, and we'll see that the state is remembered, actually. So I can make this 1, 2, and 3, and I can kill the counters, bring them back, and we'll see that it's still 1, 2, and 3. And the reason why that happens is because, well, it is looking back up into this map and it's finding the atom. And that atom has been kept alive in this case. So even though it was dismounted, unmounted, that state was persisted. If I remove this line and try it again, and I can do that in the code, I will not update the actual display, the simplified version of the code, but just know that I just deleted this line in my actual code that renders these atoms. And if I bring it down to 0, bring it up, increment, this time I'll go 3, 2, 1, bring it back down to 0, and bring it back up. They've sort of reset themselves to their initial state. In this case, it was 0. So that's kind of what keep alive does. It will reset your atoms when they get dismounted or unmounted. But that's basically how you do it. If you want to have multiple independent pieces of state, you would make a family with some identifier. Sometimes this ID is pretty obvious what to use. If you have some kind of entity that has an ID and you want one component per entity, well, you can store the states in a family with the user ID or whatever kind of UUID you want there. In this case, it's a list of atoms. It's a list of counters, rather. So they're sort of just identified by their index in an array. I don't have that example code right here right now, but yeah, that's basically how that would work. Let me see if I can very quickly render the counters. Where's the code for this?
What does the label do in Atom Kit?
Yeah, that's a great question. I forget. I just kind of added it. I think if you have some kind of logging, it will show you. But I don't have any logging right now. So
Yeah.
yeah, we got to get Tim on here one day. That'll be tricky. I don't know what time it is. It's like 3 weeks from now in New Zealand.
It is 3 weeks from now. Yeah.
So we'll have to figure that out. But yeah, let me see. Probably you actually know you don't need the with label. I don't know why I even have that with label. Let me find that code in my example.
The uniqueness of the map key is dictated by the parameter passed to atom.family.
Yep.
That's the thing that's used for the map, like underlying map. And if I recall correctly, atom.family, the parameter respects the equals trait from effect. So if you implement equals and hash, like a hashable equalable data type with effect, like if you use data or schema, those types implement equals for you under the hood. If you can pass those more complex keys, and I think that will still work, because under the hood, I think it's using a mutable hash map. Yeah, anything of type data or schema would work. Here we're using a simple number, but yeah. Tim sometimes does join these chats and lurks, usually towards the end. So,
all right, fingers crossed, and we can get back to this. I threw this in there, the actual example. So this might be what it looks like under the hood. We have an array of length num counters. I mean, we're just using it for its indices. There's probably a better way of doing this, but I just had Cursor poop this out for me. So yeah, we're just kind of going through and having however many counters we have, which is determined by another atom, which is the count atom, how many counters we want, the count of counters.
count.
Yes. So that would be, this is the count. No, wait, where's the count? I've somehow deleted everything. So I think that's probably my fault. I will undo this because I've broken the page.
Wow.
But yeah, that's kind of the idea.
We've got Dylan in the audience today. Welcome, Dylan.
Oh my good God.
There's a celebrity in this.
Oh, wow. Hello, Mr. Mulroy. If you have any questions, you have to get in line and call in. No matter how handsome you deem us. But it's great to have you. Yeah, how do you stream all the time? How do you do streaming? Does your brain turn off? Do you eventually adjust to the streaming psyche, the streaming mindset?
I haven't seen Dylan stream in years. It's been years.
Well, he's been doing work, I guess. We're talking about Effect Atom. I've got to bring Ethan. Hopefully, Ethan will join us one day because he's done at least some production Effect Atom in the whole Vercel domains search effect. Woohoo! This uses Effect Atom, I think. There's an atom under there. Can't you sense the atom? Oh, Effect.apartments. Boom.
Man.
All right. Bug report real quick. This shows the chevrons are facing towards the right, but I press it and it goes to the bottom. So I feel disoriented. Also, the remove text is black on gray. I can't read this. Now I feel lost. So I don't know if you join this to get some tasks, but open up Linear right now. And there's 2 for you. I'm disoriented and I can't see. And now I can't buy anything. Oh, Effect.black.
Wait. They black out.
Maybe it's only for Effect.black that it does that.
They black out the remove. They blank it out so that you can't actually remove it.
These are dark UI patterns. These are literally dark UI patterns. But no, this is such a good website. Anyway, create next step. Yay. Cool. Well, that's it for that. That's all I want to talk about. Oh yeah, you got married. Congratulations, Dylan, and enjoy your PTO. I'll send this recording to Ethan.
We'll schedule it to be sent to you when you return from PTO.
Yes. Okay, cool. So, well, we have a caller. Lloyd is calling in with a question. I'm going to bring you in, Lloyd. Let's see what happens. Check mark. Lloyd.
Hello.
Nice to meet you.
You too. I have a question about using effects for like more primitive libraries, I guess, just to sort of veer in the complete opposite direction from.
Oh, that's totally fine. That was these do not have to relate at all to whatever we were talking about.
So I had in the message I added an effect playground, but I can probably drop it in the chat if I can find it again. Cam's chats. It's in here. I think that's, or no, sorry, that's without the this one. So essentially, I took a lot of inspiration from the effect printer library, but really needed to do Flexbox stuff. So I sort of reverse engineered it with a bunch of stuff from Haskell, and I ended up with a little library that does sort of Flexbox stuff. But it followed a lot of the same patterns as printer, meaning that there was a lot of like the use of effect was mostly in sort of like primitive use cases. So it would be things like pipeable, hash equals. And then looking through other libraries, I added things like inspectable. But my understanding is that this isn't quite the correct pattern going forward, and that rather than having these sort of primitives and these sort of like safe and unsafe functions that might be wrapped in effect and then unwrapped again, the whole API should be rather effect first. So the object that I'm, or the class, I guess, or I guess it is an object in my case, that I return rather should be wrapped in an effect itself. And then this sort of like percolates its way down throughout the whole API. And I've tried this once, and it just exploded into red spaghetti. So I was wondering if you had any sort of tips or suggestions, or maybe I'm going in the complete wrong direction.
Yeah, I don't think that there's for if your library does not require you to perform side effects, like if you're taking in a data structure and interpreting it, which is basically what printer does. I don't think there's really any reason to make the whole library effect first. I think you could use pieces of the effect like you were doing before, like you were saying with some of the traits and some of the like data types, like making things pipeable or inspectable or whatever. But yeah, I don't think there's any need to like shoehorn effect in where it doesn't fit. I think if there's places where it does fit though, like when you actually go to do the rendering, like in printer, the only place I really actually utilize effect itself, besides for like some of the internals where I needed stack safety, the only other places that I use effect is like the rendering pipeline. So I would say, looking at this, I haven't scrolled through the whole playground, but there's no reason to shoehorn effect in if it doesn't fit or if you don't need it. I think if we take printer as an example, the places where I've used it was for stack safety and for like just the interpretation of stack safety when interpreting the document structure and rendering. So yeah, I don't think there's any reason to, if you don't need it, you don't have to use it. That makes sense.
I think the use case I had, or like the justification I had to say that I could use it, is there is I think it's a char function where I can find the line 100 something to string. It is 168. There's a function where I essentially take the first letter of a string, and like theoretically that could fail, or like it sort of like silently fails, because I think I have a fallback if the first index is 0. So this sort of like feels against the functional, I don't know, meta of like exposing these sort of like errors if someone's like really that dumb to pass in an empty string into a string character or something.
Yeah, I mean, I don't know. I think that is, there is like a, what's the word I'm looking for? There's a purist approach, which is like, oh man, if anything could possibly ever fail, we need to like wrap it in an effect or something. And then there's like taking the invariant approach, which is like, we can't enforce it on the type level, so we're just going to throw an error if you do something really dumb
Mhm.
and mark it as like an invariant, which I think I do that in printers somewhere in some places, maybe. And there's even some places in effect where we do that. Like, I think this is a case where like the justification for introducing effect, which then would have to like percolate through the whole like data structure. I don't see the importance for just like indexing into a string, if that makes sense.
I think actually in the rendering thing, at least in my implementation of render here, I do use effect because I use it for injecting in the different renderers. So the same render function can be used then to pass in like an HTML renderer or an ANSI renderer or a I can't remember what I did, but then effect was like super useful.
In other
That is
languages, like oh, sorry.
No, I was just going to say that's an actual concrete use case where I would say effect would shine. Is if you have the ability to use multiple different renderers, you could use effect to like inject the renderer. The other way to do it, obviously, is to have different rendering methods. But if the logic is the same and there's just pieces that need to be swapped out, then like, you know, injecting a renderer makes a lot of sense. So, sorry, kid, I didn't mean to talk over you.
No. I was just going to recall some past rules and laws and things that I've heard from my Scala and Haskell days. You know, you'll often hear in more functionally, I don't know, disfigured communities, more functionally obsessed communities, functionally pure communities like that. The principle of least power, right? And you're always supposed to pare things down. And well, if you're not using side effects and you just want to read in arbitrary, rendering dependencies in some nested place, and use the reader monad. And so you have to rewrite your whole program to be these different minimal monad transformer stacks. And sure, maybe that's more pure and maybe more mathematically lawful or minimal, but it ends up, many people listening might not know even what those words mean. And I think, our approach in effect, which I really like, is just to be a little more practical, use the power. Like, how does it feel to rewrite everything in effect? If it gives you some cool powers that effect gives you, and those are useful to you, take them. And if not, if it makes everything corrupt and weird and gross and onerous to write, then don't use it or just use it in some places. So I think whatever makes the most sense. And I think in CLI, we do throw in some construction cases, right? In some constructors, if you pass in values that just don't make sense. And I think, there are trade-offs to that. Having, every method that creates a CLI option return some kind of either structure would be pretty annoying to work with. And those tend to be constructed once at the top of your application. So throwing in that case seems like a reasonable trade-off. It's not like it's going to blow up unless you're using effect CLI in a very strange way. During runtime, it's going to blow up right away, probably when you're developing the program, because those all tend to be sort of constructed statically once at the top of your application. But I don't know. It's whatever makes you happy, I would say.
Fair enough. Maybe as like a quick follow-up, like I've only sort of like, I feel scratched the surface of the, I don't know what you want to call them, utility decorators, like hash and things like that. Like the ones I've explored so far is equals hash, pipeable, and inspectable, but I've seen in a couple of your other streams you using other ones in more of the internals of the library. I was wondering if there are any others you think deserve showcasing when sort of creating these sort of like very low level objects.
I think maybe the only other cool one I would bring up is in 3.0, it's called effectable. Which basically means a data structure that can be interpreted as an effect. So on its prototype, in 3.0, on the prototype, you would have a commit method, which returns the effect version of that like data type. So you have like an interface that describes a data structure, and you can make that data structure like extend effectable, which means like if you yield it or you flat map it or whatever, it gets treated as like that effect. In 4.0, we took a slightly different approach because in 3.0 we leveraged subtyping to do a lot of different things. So like you can like you can flat map options with effect.flatmap, and it gives you then an effect of a or an unknown exception. And you can do the same thing with like ref, which calls underneath the hood. It calls like ref.get to get the value of the ref. That turned out to be like a massive foot gun in many different places. So in 4.0, we took a little bit more of a pragmatic approach. So there's still the ability to turn a data type into an effect, but instead of calling it effectable, we called it yieldable. And in a generator or an effect.fn, like anywhere where you have an effect generator, it makes that type yieldable. Like you can yield star that type to interpret it as an effect. But you can't do like an effect.flatmap on that type. So it gets rid of the foot gunniness, but preserves the flexibility. So the method, instead of being called commit in 3.0, which is what it is in 3.0, in 4.0 we called it asEffect. So it basically like converts your type into an effect. So like for example, let me share my screen for a second, Kit. I'm just gonna quickly pull up the 4.0 code base, and I'll just show this really quick. Share.
Is that kind of like how the result from Adam can be yielded in an effect and return back the success? Or is that like something on its own internals?
Sort of. That for Adam, it's a little bit, it's slightly different, but it's along the same line. Yieldable. Yes. So I'm just gonna open a Scratchpad here and show you guys what I mean.
Could you zoom in like 3 ticks?
Yeah. Hang on. Let's see. Is this big enough?
Yeah, thanks.
Okay. So let's take like option as an example in 4.0. So this is the 4.0 code base. And in 3.0, if you have a generator, you can do this in 3.0, right? You can yield an option and get back its, oops, I need to. God. Just to get Mattia's LSP to stop yelling at me. This is like valid code from both 3.0 and 4.0, right? You can yield an option which will interpret the option and try to give you back the value, or it'll fail with a no such element error. In 4.0, we replaced the exception terminology with error. So this works in 3.0, but this also works in 3.0. Flat map option.sum 1. Or we could just say void. In 3.0, this would work. In 4.0, you see you get a type error, where basically, somewhere in here, option number is not assignable to type of effect. And that's because we removed the concept of subtyping in favor of being more explicit. So you have to call like asEffect here. So if we look, so getting back to your original question about like traits and things like that are kind of cool, go look at option in 4.0. You'll see that we have this yieldable trait, which explicitly marks these types as able to be yielded in an effect generator. And what this basically says, if we go look at the trait, you have to implement an asEffect method on your type. So for options, making an option yieldable gives you, so if you look at yieldable, you get the self type, which is whatever, but then you have the ability to specify the type parameters of the effect that you're transforming that type into. So here we say this option is a yieldable type that returns either a successful type of A or an error of no such element exception. In 3.0, this would look like something like effectable A no such. So sometimes this pattern is cool. I think like it's a little bit more dangerous in 3.0 because, like I said, the subtyping is a little bit of a foot gun because you can't control. You can't when somebody flat maps an option in 3.0, you can't with effect you can't like raise a type error. It will just auto flatten the option. But yeah, so that's like maybe one of the other traits that I think is kind of cool. I don't know, Kate, if you have any other like traits or anything like that that you can implement in effect that come to mind.
No,
But
I'll try. I wish I could think of some secret hidden traits. But no. I think you covered it as far as I know.
primary key is another one that's used in a few other places. These are like, it's getting really in the weeds now. But like primary key is another trait where you can mark a type as having the ability to extract a primary key from it, which is useful. I think we make use of it in like effect cluster and a few other places.
Both of which made me not so useful for creating a sort of a text box type interface as you're doing in this case. Maybe.
Yeah.
Really
I think
create
you like you raised the most important ones, I think, which are definitely like pipeable or most useful ones, which are like hash equals pipeable, inspectable. Those traits are kind of useful, really useful for all different types of data. So
yes,
we should go over in some future session how to use it, like come up with an example of implementing this for custom data types. It's definitely an advanced technique, but since you're building sort of more low-level library code, yeah, I think that'll be a cool thing to cover sometimes instead of just more entry or intermediate stuff.
Very useful.
Amazing. Well, cool. Thank you so much, Paul.
Welcome to Spain.
Oh, and just to let you know, RJ and Tyler, I see you, and you will be next in that order.
Merchant.
Hello, Shane. Nice to meet you.
Hey, nice to meet you. Thanks for all of your work. I've been enjoying it and using it a lot lately. So I have two questions. One is about OTel, and the other is about file system stuff. I think I got the OTel one. So if I have an effect running and I put effect with span on it, I get my traces. That's really good. If I call effect.fork daemon, I don't ever get whatever happens in that like daemon fork. Never gets back to the original, even if it's sort of a relatively short-lived. I just want to run something in the background, kind of as a side effect. But I would like any telemetry events from spans from that to still be linked to the original. And at least from what I've seen, if I just do effect.fork, not the daemon version, if I await the fiber, I do get them attached. And if not, I think they just kind of never showed up. Is there any way to link those?
So we probably would need a little bit of like a if the behavior you're describing is what I'm thinking it is, we might need like a little bit of like a reproduction to investigate it. But in order to fully link the fiber that you're running with the span coming from its parent, you would have to either await the fiber, which is what you described you having to do, or I'm not exactly sure 100%, but have you tried annotating the forked fiber with like an effect out with parent span?
No. Is that the secret? Okay.
You could try. I honestly don't know the correct answer. I haven't experienced this particular issue myself yet, but I can look into it on the 3.0 code base and see, while we're chatting, and see if I can figure out a solution for you.
Yeah. Okay, cool. Yeah, I did this. I think I wrote in the note. I did this with a queue, but what I did was passed in the span ID of the parent so that the child could start something and manually set that value. Which seemed to work to be okay, the stuff that happens from the queue is related to this original invocation, and that works pretty well. I was hoping there was an automatic way to do it for forks, because I don't want methods to have to, or I don't want that function to have to take some span ID.
Yeah, it sounds like something. I mean, off the top of your head, Maxwell, does that sound like something? Maybe a bug or something?
A forked fiber should be inheriting the span context from the effect that it's forked from. Like, it should be inheriting the parent span, I think, automatically. And if that's not the, like, for a forked daemon, you're actually forking a fiber. You're destroying the parent-child relationship. Essentially, when you do a forked daemon, you're destroying the parent-child relationship of like the effect that forked that fiber, which is the parent fiber, and then the child. When you fork daemon, you're saying fork this fiber and attach it to the global fiber scope. So you've essentially now got like, it's been added to like the global fiber scope. So that might be why you're seeing a detachment. Have you also experienced this behavior when using other variants of fork, like fork scoped or just forking the child directly?
Yeah, forking directly will cut it off unless you await the fiber.
Okay.
And I think I have one forked scope, but I couldn't tell you off the top of my head how it's behaving.
All right, I'll look into it and see if I can't figure this out. Ping me in the office hours thread, so that I know who to respond to once I have a good answer.
Okay.
Also, just a public service announcement, and I'm not admonishing you, Shane, because that was a great question. But if anyone can bring a reproducer for like, that's a great specific question. But if you can even, obviously, then we could like share it and look at it right away for next time or for other people. But once again, thank you, Shane. You have a second question too, right?
Yeah, I've seen within within platform, you've got file system, and you've got the node implementation of file system. Are there any plans to do anything else? Web-based file system, MFS kind of things.
So there's a node implementation. There's a Bun implementation. I don't think we have a platform deno, so we don't have like a deno implementation, but we don't currently have on the docket like any web-based file system implementations on deck. In 4.0, we do have like an in-memory file system we're toying with just for like testing purposes to allow people to test. That being said, like, we're always open to ideas and suggestions and also contributions. So if somebody's like built something like that and they want to upstream it, like, feel free to open a PR and we can like hash things out in PR review. But we haven't like specifically talked about web-based file system support for platform. But we have like a platform browser, so it's not an unreasonable thing for us to consider in the future.
Are the APIs basically identical? I hadn't looked into that yet or heard of it.
It depends what you're using. MFS in the MFS, that one is meant to be a drop-in replacement for Node. I think they're sometimes slightly behind on like the very latest cutting-edge stuff, but they keep it pretty close.
But read file, write file, the classics, those would be cool.
Yeah, they've got watch. I mean, there's a ton. Like it's like 99% correct and complete.
Okay, cool. That would be good. Do you know what people use that for? I mean, I imagine many things, but have you used it in Anger?
Yeah. Right now we're doing some browser application stuff where we don't have a file system, but we need to do file system like things for, imagine like IDE in the cloud type scenarios.
Okay. Very cool. Okay, amazing. Node. Lloyd asked, what about Node? This is kind of related, so I'll just pull this in here. What about Node crypto? Is that something we'd be open to for something like, I'm not sure if that comes from platform Node.
We don't have a crypto implementation yet in platform, but none of these things are out of the question, if that makes sense. They're all reasonable things to consider in the future. I think we just have to like take the time to find like the whole point of platform is to provide like a unified interface across all of these APIs. So sometimes part of that is like looking at the different platforms themselves and like figuring out what we can support in a generic way. but yeah, I don't think it's out of the question. Crypto is a good example. There's a Node crypto is a good example. There's also I've reached for oh god, what's the other node? I'm not gonna. I just lost it. It's gone. But crypto is a good example of like something that we could consider for platform in the future for sure. And Kezin also asked a question about tracing, which was, how does one yield the parent trace out of the context? So you wouldn't yield the parent trace. You would yield the parent span out of the context. Like you'd get access to like the parent span, not necessarily the full trace, because you don't have the full trace information at that point in time. And I'm just searching the API documentation for the method in question. It's like current span or something like that.
Did they share it right here? I think parent span yield tracer.parent span. Or is that different?
Tracer.parent span. I think that is it. Yes.
Cool.
Let me just. So there's. Yeah. So there's in the effect module, there's an effects.currentParentSpan method or effect, which grabs the span, the parent span from the context, or raises a no such element exception if there's no parent span in the context. Tracer.ParentSpan. Let's see what the thingy is.
We should also do an episode on all the tracing stuff. That seems to be like something that everyone really enjoys.
We definitely should, because like with span is cool, but I think where people are very interested in tracing is like integrating with external systems and also propagating external traces into effect, like when you're incrementally adopting effect. So anyways, definitely things to consider for future office hours.
Cool. Well, we have a couple. We still have RJ and Tyler. Shall we? Are you all good, Shane?
Oh yeah, thank you.
Fully enlightened. Okay,
Shane,
perfect. Thanks so much. See you soon.
Thank you very much for your questions, Shane, and I'll follow up with you in the office hours thread.
Hello,
Hey.
RJ. Hello.
What's up, RJ?
Greetings.
Hello. Greetings. So, thanks for doing these office hours, by the way.
Oh,
it's great to have an
our
opportunity
pleasure.
to ask these kinds of questions. I'm working on a library, and it's an effect library integrating sort of effect with another service. And I have basically the same problem that the HTTP API, particularly the pattern of defining an interface and then having a client that you can derive from that interface, and then like a server that you can also, I guess, derive from that same interface. And so I built, I figured that I should just use that as reference code and try to build the same API, especially as Effect users will, if they use the platform module, they'll be familiar with it. And I'm having trouble understanding how layers are used in that context. I guess generally how maybe how it's all wired up. But what I mean by that exactly, maybe for those who aren't familiar, when you define like an HTTPI, you can define endpoints. Their interface is using schemas. And then you can also put those endpoints in groups. And the way you provide implementations for those endpoints, whether they're organized in groups or not, is by using an API function which produces a layer which you then provide to something. And then once you've satisfied all those requirements, then you can create a server or whatever. And so that's my question.
RJ, are you the RJ of Confect fame?
I am. That's what I'm working on. Yeah.
Very cool. I actually was toying around with just getting set up with that library not too long ago, and then got distracted.
Oh,
But I want to very briefly mentioned my little Dadbot app that I've been working on as a little demo for Effect AI, and I was going to set it up with Confect. So maybe I'll have to ping you.
yeah. Please do.
But really good stuff, by the way. Yeah, I think maybe we can like talk through a few things, and then like maybe that'll like flesh out some of a little bit more about the question that you have. But I think the goal that we have with HTTP API and other APIs that kind of are like this. So, for example, RPC is very similar. The AI toolkit is very similar. The goal is to have a spec for the API definition separated from like the actual handlers or the actual implementation. So you define your spec, and then you define like the implementation elsewhere and that's when you take your spec and transform it into a layer, so to speak.
Share, by the way, I found something semi-relevant that we can use as an example. There's an example here in the changelog for very similarly the OpenAI tool or the AI tool set, which has the same pattern of, I could just show everyone who may have been confused. You sort of declaratively define some structure. So you have this dad joke tools, once again, Maxwell's go-to example. And you have a get dad joke, which is one of these AI tools. It has an output, which is a successfully generated dad joke, which would have a schema probably above. And then also the inputs, these parameters, which is a search term. And this is obviously just defines the interface. It's very similar to defining a function interface or a type signature, except it's done at the value level so we can inspect it and generate stuff from it. And you might have multiple things in this toolkit, but right now there's only one function. But you might imagine that you'd have multiple functions. And similarly, in the HTTP API setup, you have an HTTP group, which would have multiple HTTP endpoints that are defined by their inputs and their output parameters. So very similar thing. But this is not the implementation. This is just the interface. So you have to generate some implementations for that. And so this object that you created, this dad joke tools class, will have a two-layer method on it, which will constrain you in a very type-safe way to return an object that mirrors the names of these various tools. And the output type you'll be given basically the input parameter types here, whatever you denoted there, and you will have to return the output type. And this can obviously use any effect services you want. And this is the actual implementation. And therefore, you can easily make multiple layers that satisfy the dad joke tools. And whenever you use dad joke tools, you don't mention any implementation. You sort of use it abstractly, like it's an interface. And then, so this make dad joke would depend on some dad joke tool layer, and you would have to provide that basically at the top of your application. It's kind of the same reason why layers are used in general, to just like separate interface from implementation and make it really easy to swap out different implementations. So it's a pretty interesting pattern. I like it. I don't know if you copied this from Zio World. This is kind of from the Scala Zio code base. It seems like your own sort of take on it, and you use it in lots of places, and it's quite elegant. So I don't know. That was the context. I'll yield back to you, Maxwell.
I actually copied this from Tim because when he refactored RPC to use this pattern, I really liked it, and I was like, this is a great fit for tools in AI as well. The reason why I don't recall the exact reasons why we can't do this with the HTTP APIs. Like you have to have like that handlers thing that gets passed in, and then you have to implement each handler off the handler's object, whatever it is. So it's a slightly different thing where when you call two layers, you get like a handlers thing that you then have to like implement. Tim would have to like be here to explain why because I asked him at some point, I was like, can we refactor HTTP API to have this interface because it's much cleaner? Because RPC and AI and a few other things use this. And he had a good explanation that I forget now. But Yeah, the whole point of this is to separate spec from implementation. And the other reason why this pattern is implemented is to allow the implementation to rely on arbitrary services, which would actually be quite difficult to do without like the service pattern that layers allow you to do. And when I say like service pattern, I just mean like this little closure that we create here where you have an effect gen that yields the services you need and that closes over those services, and then you can return the implementation elsewhere. So RJ, with all of that context now, could you elaborate on like your question a little bit more? Just now that we've given context to the audience.
Yeah. So, so hopefully this isn't too much, but I'm trying to do this for the library that you mentioned that I'm maintaining, and so I'll explain a little bit more what that library does. So this library Confect is meant to provide, sort of be like effect bindings, be like a kind of effect integration with Convex, which is a kind of back end platform, you could say. And Convex allows you to define functions, which are like serverless functions like lambdas. They also have a database. So some of those functions are actually queries or mutations, they call them. So these are functions that can read or write from the database, from or to the database. And then there also are what they call actions, which is just you can have any kind of side effect within the context of an action, HTTP, whatever. And you define these functions, and there's some CLI thing, and it deploys them for you, and all this kind of stuff. And so what I want to create. So I want you to be able to use schema to define, just like how I think the RPC and HTTP API libraries work. I want you to be able to define your convex function API using schema, and then be able to, without any manual effort, invoke one of these functions with arguments that can be encoded by the schema, by the argument schema, and then have the result be decoded by the whatever you want to call it, return value schema. And so right now I don't support this. And so like if you look at that example there, if you want to do this, you have to do it manually, and so then you have to extract the schemas for the functions to a different file, and then you have to share that in both the implementation of the API of the functions, and then you have to kind of manually. I have some helpers for it, but it's still basically a manual process. So that's what I'd like to do. It's basically, unless I'm misunderstanding something, the same thing that both HTTP API, that those sort of modules do, and also what RPC modules do. And does that make sense?
I
can
think
explain.
I
I guess that's not a question. That's just like an explanation of the context, more so.
Yeah, maybe you could get into like the question, like what concretely are you trying to, are you struggling with or trying to achieve, and we can go from there. And if we end up running too long or whatever, we could always take this offline and like chat about it more. But like I'm interested in Confect because I'm also interested in Convex as a platform, and I think it's kind of cool. So yeah, feel free to elaborate on your question, and we can see if we can get somewhere.
Okay, great. So the question is basically, so I have a sort of working draft implementation of this where the types all work out, but the way that these layers are used, the way that you create an implementation of, say, like an endpoint, and then provide, or a group of endpoints or whatever, and then you provide that and then you do the normal thing with layers, or you sort of compose them, or they are composed for you, and then you just provide the implementations as necessary until you've satisfied all the requirements. I'm not familiar basically with. I'm fairly comfortable with using layers in that way, but I'm not. I'm not familiar with building this kind of API where I'm sort of creating layers, but it seems like in these HTTP API modules, and I think also in RPC, there's something going on that's not that's different. It seems like you're sort of getting layers at the type level, but then there's some runtime level hackery to kind of make it work, and I don't really understand that disconnect. Does that make sense?
Yeah, I think I sort of get where you're getting at, and maybe we could take a look at like a concrete example of this. Let me go to the 4.0 code base. The 3.0 code base, wherever it is. There it is. I've got like 12 terminal windows open. One sec. Let me zoom in for the audience, and then I'll share my screen. I'm going to do this in the context of AI because that's what I'm most familiar with. Screen. Tell me if this is too small or too big. Let's go look at toolkit. So Kit showed an example of defining a toolkit before, where you define some tools, they get merged into a toolkit, and then eventually that toolkit gets turned into a layer. And you do that by sort of like, let's go to maybe the Scratchpad, and hopefully I don't leak anything important in here. Yeah, so like here is an example of like, here's two different tools that are like, not really doing anything. And then I compose these into a toolkit. And then by using this tool, I can take this toolkit, I can turn it into a layer. And this layer returns, among other things, it returns handlers for these different tools. So if you actually look at like a program that uses the toolkit, you'll see that this program requires, if we were to go down here. Well,
and I believe in V4, you've made this much less verbose as well, right? It'll only sort of reveal the type name.
Yeah, it's still, there's a little bit of verbosity, but it's not this. But the point is that the layer gives you the implementation for the handle, like these tools that you need to handle. It gives you you create handlers for said tools. And these are the things that end up in the context, these like different handlers. So like when you create a toolkit, you need to implement handlers for some tools. And like when you use it, when you use a toolkit, the program's going to require those handlers, and you satisfy those handlers by converting the toolkit to a layer. So I think that what RJ mentioned is kind of true. There is some like I'll call it like hackery that we do, but I think it's not so much around layers. It requires a small bit of knowledge around context and effect. So the context object. So and we can take a quick step back and make sure that we understand that all a layer is, in reality, is just a lazy constructor for a context object. Like when you have a layer graph that you've composed together in your app, and you go and you effect.provide the layer, what happens under the hood is it gets built into a context object that has all the services that were in that layer graph that you built. And it's just like a single context object that then gets provided to the effect, and it runs with that context object. So layers...
And that's essentially a map, right, from the keys, which are those tags or whatever, some kind of a value identifier that is unique, that can be used as a hash key. And then the value is the actual implementation of the service, most usually.
Yeah, so the context that gets produced by the layers is literally just a map of tag to service implementation. So you end up with like this nice thing that can be passed to the effect. So when you call like toLayer on an AI toolkit, for example, if we use this as an example, it's going to take that layer and it's going to build it into a context. And really all it does is it extracts the current effect context. And I'm going to go through this like line by line, and then we can talk about like what's actually going on here. We
Can you bump it up just 1 degree? I'm anticipating someone's eyes are hurting. Perfect.
So what really ends up happening here when we take a toolkit and we convert it into a layer is we go through, like in this case, these handlers, you can imagine these are if we open back up that example I had, which I shouldn't have closed. Oops. Hang on. Scratch pad. So when you call toLayer here, you've got this, what eventually happens is you get like this object that comes back, right? In this case, all we do is we go over the handlers here. We get the name and the handler. In this case, we extract the tool from the toolkit that we're interested in. And in this context map that we're building up, we take the tool ID and we map it to the handler for that tool and the context that we extracted at this point. This is like slightly more advanced. You don't have to worry about this piece of context. What's important here is this map that we're building, where this map is essentially a mapping of the tool identifier to the handler for that tool. And then we literally just build a context object out of that, which you can, and layers, because layers are just constructors for contexts, they have constructors on them that are like meant to take in a context object. So there's effect context where you have an effect that produces a context. There's like succeed context, which literally just takes in a context object. So we can talk more about this offline, and I can show you how like these APIs work. But all that's really happening is when you call toLayer or you take an HTTP API group and you implement it, you're building a context object under the hood that maps like whatever endpoint or tool or RPC to its handler, so that when the toolkit is actually evaluated by whatever program needs it, it can extract the handler and use it. So like toLayer builds the toolkit in this case, and then this method over here is what actually uses it. So if we look here, where is my context? Here we go. At some point, I have gotten a reference to the context of this effect, effect.context. This is a context object. And this is like, we're dropping down to unsafe code here, right? This is a context object that I unsafely try to obtain the tool ID from. And if I get it, I get the handler back. So this handler, then I can actually use in the handle method for these tools. And this like pattern of building up a context object and then providing it to the effect that needs it to run is basically what all these APIs are doing under the hood. Is you build up a context object and then you provide it to the effect that needs it. So like the types allow us to make this all type safe, but under the hood, we drop down to a little bit of type unsafety to do this stuff. I know this is like, there's a lot of like even implementing this stuff, sometimes you have to like slow down and be like, okay, like, am I making sure that I'm propagating services correctly and everything like that? But I promise it's not so bad, like trying to expose these APIs once you sort of like grok it. So if you want, we can like help with implementing this for Confect if that's something that you're interested in.
Yeah, and I know layers are very generally a complicated topic. Very useful if you just use them in their basic as a consumer, as and not a library implementer. It's still difficult, but maybe an order of magnitude less difficult than having to use these patterns. But yeah, if you just think of the context, the requirements is just a map from some kind of runtime identifier for a type of a service, and that maps to an implementation of that service. And so you just have a map of these things. in regular effect code, when you try to yield a tag from as an effect, all it does is it gets the context map that's kind of been in scope and looks up into that map with that value tag that represents that service, getting the service out. Which means at some point earlier, when you provide a layer, it goes through the tags that you've provided with that layer. Because when you define a layer, you have to provide its tag as well in the implementation, and it'll just basically set into that map that implementation. So you're just taking something out of a map, counting on the fact that later on, someone's going to put into that same tag the right implementation. So it really is dependency injection, and it's sort of analogous to function calling, right? Where you have a function that defines its arguments. You can't call that function without providing the arguments. So sort of yielding a tag is kind of like looking up into a map for that argument, and then the sort of the TypeScript type system, and the way that these requirement parameters, type parameters accumulate, ensures that at least at the type level you cannot run your effect before all of those parameters have been put into the map correctly, which is how it all clings together. And what's only different about this implementation is that because you're not using the standard sort of yielding of a tag, and instead you want the nice API of constructing an object with string keys, it has to go through some special hoops to ensure that when you actually call it, it knows how to deal with those string keys, because it's sort of taking a slightly different avenue to populating and reading from that map than the usual like context.tag behavior. I'm going to talk. I think we should also devote an episode entirely to understanding how layers work with some nice examples. But yeah, anyway, back yielding to you again, RJ.
Yeah, that makes sense. I think that that was roughly my understanding of what was going on. But I think what's hard is that because it is unsafe code, these implementations, it's hard for me to feel not fully understanding what's going on, and not having any kind of type safety makes me very wary that I'm gonna like do something wrong, basically, or and certainly, like you said, also requires slowing down and probably testing things really carefully and stuff. So, but anyways, that makes sense generally, and I would love a little bit more guidance if y'all are willing to offer it.
Yeah, that sounds like a fun challenge, like a fun live coding thing to do anyway. We should prepare something for some future episode. Do you think it would be possible, Maxwell, off the top of your head, to have some kind of abstraction that kind of deals with that generically? The sort of object, string key object implementations that you can then provide later.
I mean, we could fake one, but I think like really all that's happening at the end of the day, like if you build up an RPC group, let's just like go back to RPC for example, because like that's an easy one to like map this to, right? If you have an RPC group that has like I'm just gonna literally make stuff up here. You have like get users and I don't know, list users, and this is like your RPC group. When you actually go to convert this to a layer, you do like RPC group dot to layer, and then you have to like implement get users and list users, right? And this produces like the layer. And if we like were to inspect this in the actual, I would write this out, but I don't want to. Why can't I type right now? Okay,
whatever. Character? What symbol are you looking for?
Literally a caret.
That would be shift 5, I believe. There we go.
It's shift 6.
Oh no, it's shift 6. Oh my god, no wonder.
I don't know what was going on there in my brain. This layer would have like an RPC dot handler for get users and or whatever you want to for list users. So the layer type here would be like a layer of this, right? You have, when you go to implement this RPC group, you end up with a layer of RPC handler, get users, and list users. And what Kit was mentioning before is true. Like these are not real tags. They're like fake services that they're not fake in the sense that they don't exist. They do exist, but they're not tags. They're fake services that we put into the environment to indicate to the program that you need these handlers in order to be able to actually run.
Mm-hmm.
And this layer will produce these handlers, so it'll erase them from the program that eventually uses said RPC group. But under the hood, like what actually ends up happening is when you do this like 2-layer thing, 2-layer will actually produce a context that has like, I don't know, name. I'm making this up. I don't know what the actual context looks like, but it'll be like this, and then it'll have another thing where it'll have like several entries in the context that represent these actual handlers. And a context can be converted into a layer just by like using one of the layer constructors I showed before. So like this 2-layer, these methods, all they do is produce a context that contains these handlers. So we can talk offline, RJ, about like doing this for Confect if that's interesting to you, and maybe we can like toss around some concrete code examples, or if you want, we can like, do this next office hours live. I don't really care. But yeah, that's really all these APIs do under the hood, is they construct a context object, lift that into a layer, and then allow you to provide that to a program to erase dependencies.
Mm-hmm. Cool. Yeah, either one would be good. Like I said, I have a working implementation at the type level, and it's actually it's sort of like it's a little more complicated than the HTTP API machinery, because I wanted to support. Maybe this is I think this is the right decision. This mirrors at least what Confect supports. I wanted to support nested groups, so groups could have groups. Groups can have endpoints or groups, right? And all the types seem to be working. So it's really just the implementation that I think I need to, like the value level implementation that I need to understand and do correctly. So maybe that's at least hopefully well scoped for the sake of a discussion, either offline or next week. I'm happy to do either.
It could be, if the audience is interested, we could have a discussion about it next office hours. It would be a good opportunity to dive into like some really low level stuff with layers and context or whatever. So it's up to kind of the group, but I would be fine doing that next week if we want to.
That would be great. I've it's on my to-do list somewhere to make some kind of visualization for layers, and maybe I was kind of going to use the New York City meetup as a deadline for some kind of layery presentation. Maybe I could use this also to prepare something slight, a simpler version of that for next week, just to give some context to everyone visually about what the heck's going on. And then we can dive into a media example.
Cool. Cool. Well, thank you very much, RJ. Did you have another question, or was that we can touch base offline about like setting something up for the next office hours, but I think it would be cool to try to do some live coding around this. It'd be interesting.
Yeah, that'd be great. I think it's already mostly in a good place for that. So, great.
Cool.
Amazing. Great. Thank you, RJ. It's good to meet you. And
thank you, guys.
See you next week.
Take care, RJ.
Take care.
Bye.
Tom had a question about finalization changes in V4. Like Tim said, there's no change in finalization around V4, but Tom, I think what you're referring to is we changed the semantics around deferreds and things like that, where I forget the exact specifics, but I think in V3, if you're awaiting a deferred, that will not prevent the process from shutting down. I forget the exact semantics here. Yeah, in V4, awaiting like a deferred, for example, would keep the process running, like the actual Node.js process. In V3, awaiting a deferred does not keep the process open, if I'm remembering correctly. But finalization works the same. It's more we made that change because it was kind of unexpected behavior. that awaiting something like a deferred or something like that would actually not keep the process open. So,
Oh, Tom's calling in. Maybe with that same question. Let's bring in Tom.
Hello, Internet people. Yes, same question. Basically, I guess concretely, say I have a non-effect code base that is running in a Cloudflare worker, and I want to add some effect to it, but absolutely guarantee that the Cloudflare worker will not end before all of my effects have effected. What do I have to do in V3 so that it will keep the worker working until all the work is done?
at the very end of your program, well, you would have to do something to keep the process open. So, yeah, what Tim said is a good solution, which is there's some sort of like wait until or something like that API in Cloudflare, I think, that allows you to keep the process open, which you could use. You could I don't know the exact specifics of your particular deployment or program.
I just got here.
but you could like effect.never creates a handle that'll keep the process open.
Okay.
I think in Cloudflare as well, in V3. So you could like use effect.never to keep the that's how we keep like HTTP servers open in Effect, for example, is like effect.never in some circumstances. You could use that, but you just have to like interrupt the program when it's over. Yeah, I don't know, without knowing the specifics of the application and like what specific like situation you're facing, like those are the things I can think of. Is like you'd have to use one of the APIs in Effect that keeps the process open and run your program to a promise, or you would have to use one of the APIs that Cloudflare gives you.
Okay, so I think specifically just starting out, like I'm trying to add something that will, like at the end of a request, do some additional work after it has already, finalized, sent the response back to the user, close the connection, and do some final work like sending logs or sending some kind of a report or whatever. And I want to use effect instead of doing it the normal unaffectful way, but I don't want to, do something dumb and shoot myself in the foot. So I guess, yeah, I can follow up offline, but just like, what's a good way to like test it and verify that it's closing when expected and not keeping it open unnecessarily? Because I don't want to, effect.never and then it just keeps my worker working, doing nothing forever.
That sounds like a situation for finalizers.
Okay.
I was going to say, call like effect.add finalizer at the top, because the finalizers run in reverse order. So at the top of your effect, just add a finalizer that logs that it's closed, and maybe add some other logging elsewhere if you feel comfortable with that. That might be a pretty good sign.
Yeah, I think the code that I'm looking at right now isn't using any effect at all yet. So this would be the first effect in this part of the code base.
So Tim's solution, like here, is a very simple way to make sure that your finalizers are running, which is either adding like a layer.scope discard with like an effect log in there to the managed runtime, like basically making sure you have a layer that runs when the scope closes.
Okay.
Or add an effect, like adding a finalizer to your program with a log inside of it. If you see that log, you know that the finalizers are being called.
Yeah. Oh, yeah. Okay, that makes sense.
Yeah.
All right, cool. That's all I got.
I know Cloudflare gives some other APIs for like making sure you keep the process open. Like I think there's like a wait until API, but for a standard like effect program, I would say just use like this finalization logic that effect gives you until it doesn't work.
Sweet. Yeah, I think just to start out, having the log at the end to verify that it's doing what I'm expecting, and then I don't have to guess because then I know.
Right.
All right, cool. That's all I got. Thank you. Goodbye.
Perfect. Thanks, Tom. Let us know if it works. Goodbye. Okay, amazing. Well, I hear the sign of a sad baby in the other room, so I've got to go pick him up, give him a hug. But yeah, that was really fun. Thanks for coming, everybody. And we'll do it again next week. Sounds like we have a bit of an itinerary. Yeah, keep asking questions. See you around.
Thank you
Thanks,
very
Max.
much, everybody. Have a good one.
That's fun.